last year, I think I made it a test question, and of course, everybody finds it hard, right? And then there are different dynamic programming algorithms you can, and seeing the different ones makes it's even nicer when you do the game of life. It's more obvious what's happening. So anyway, what's our problem? Is that you have some number of stocks. I only have a little screen, so I'm going to only have 2 stocks, but you can imagine lots of stocks. And you have a number of days, right? And by divine inspiration, you know the price of every stock on every day, right? And so what you need to do is, I guess, what are our sub-instances? I guess I haven't really, I cracked out these slides mostly as a taking up the test, so I'm not sure how good they are. But what you want to do is decide what stocks, when to buy and sell stocks to maximize your profit. And one thing that I haven't listed yet is that when you buy and sell a stock, it costs you 3%, right? You can't just, it's not free. All right, so, here, this is still the instance. This table here tells me for every stock and every time what the price is. That's right, that's just, and here, what is the solution? Tells you every day, do I keep it, do I sell it, do I buy something new? And on day 1, you're gonna have $1. And, right? And, one thing that's going to be true is because you know the future, there's no sense generally you want to diversify when you buy stocks because you don't know the future. But if you know the future, you might as well buy the best stock, right? So we're going to assume that you, at every point in time, you either have a stock or you have cash, right? $1. Oh, that's, you are a troublemaker too. We're doing fractions here. You can buy a fraction. This whole idea that you have to buy an integer number of stocks is it's kind of a silly thing too, right? You can buy a fifth of a stock. Right? If you want, scale the one up to $1 million, and then we won't have that problem, right? Anyway, and what's the cost of a solution is on the last day, you put everything back into cash, and you want as much cash as possible, right? And if this was your entire problem, then it would be easy because each day you sell what you have and you buy whatever is going to go up the most overnight, right? As a percentage. I mean, that's the solution. Everybody agree with that? Right? But here I'm making it worse. And I personally don't believe in day trading. I think it should be against the law. All you have to do is charge people for every trade, something, right? And it keeps people from doing day trading, right? What? Yeah, exactly. Unless you're one of those big guys who's doing it. People are still day trading. You're not paying that. Okay, right, all right. So it should be a percentage, right? I mean, that just hurts the little guy and not the big guy, right? So it keeps you from day trading. I mean, that's no good. Right. All right, so now, because it's a cost of trading, you might want to hold on to a stack to avoid this, to a stock in order to avoid this cost, right? Day trading is bad. All right, so let's, we could talk to the bird, what is our solution, talk to the bird about what to do, but we're going to go forward with this game of life and everybody can decide which they like better. So here's an instance, right? The instance is, I'm standing, what does Pooh Bear knows? He knows it's day I, and he knows he's holding cash, and he doesn't care about the past, right? All he knows is today, it's day T. Oh, I said I, but it's T. It's day T, and he's holding cash. So, right? All right, that's everybody knows. Whatever stocks we had in the past, we've sold them, or maybe it's the first day. Anyway, we know we have cash, right? And so here's our we have a past sub problem, which is to maximize the amount of money that from the beginning to here, right? We could have that past problem. And we have a future problem, which is given we have cash here, what should we do in the future, buy and sell, in order to maximize the cash at the end, right? So you see, if I tell you right there, the fact that we're standing here, it breaks the problem into two sub-problems, which are similar, right? Everybody good with that? All right, same pre-post conditions, so we can give them our print. All right, so now we're gonna go forward. We have a bird. What do we ask the bird? Well, you're always gonna have either a single stock or cash, right? So how much to buy is never a question, right? We're gonna say, which stock do I buy now, right? And you could ask, what do I buy now and when do I sell it, right? So, or should I keep my cash, right? It's too dangerous out there. Keep your cash, right? So here, she says, buy stock S and keep it until time T prime, right? And that moves us over to here, right? Everybody buy that? And do you think that this is a good algorithm so far? I mean, think about how many edges we have. Are they long edges? They're long edges, and hence there are going to be a lot of them, right? Right. So, oh, this is just saying I don't remember how much cash I have. I have cash. I don't know how much. Right. So it's the point is how much does it increase by a percentage? Right. Right. So V, I guess, is how much cash you have here. We don't know what that is. And oh, this is just, oh, this is buying, this is a little math for those people who want to struggle with the math, right? I'm going to calculate how much money I'm going to have on day T prime, right? So V prime is how much money I have on T prime. This is how much you will have on this day, right? We'll have V money on time DT. We'll have V prime, right? Knowing how much you make is a harder, right? All right, so what do we know? We know how much money we have on day T, right? And the units, I like to balance units, right? So those units are different. This is money on this day and this is money on that day. They're kind of different units, right? So we want to get rid of money on day T, and what do we have? We have these prices. And what's the unit on this? This is kind of the unit on price for S is how much money on day T compared to how much stock do I have on day T, right? So here we can put in the price to be how much stock per money, right? And then we want to get rid of that, so we multiply by here this is stock on day T prime versus stock on day T, right? We'll assume that's a 1 because you don't change how much stock you have, right? and then we multiply by the price at day t prime, right? Because we want to balance this, yeah? Yeah. Everything's in fractions. Yeah, we're gonna. If you buy with all your cash. You sell it all. Right? Right. So anyway, it comes out to this equation. People kind of good enough with this equation? You know, you have to fiddle out which is on the top and which is on the bottom, right? Another way to think about it is, well, do I want the price here big? When I want to buy small and sell big, right? So that's why I have that on the bottom and that on the top, right? Anyway, that's our equation. And then we multiply by we remove 3%. So that's multiplying by 0.97, right? And we're not, this isn't an additive thing, right? This is a multiplicative thing, right? So we're not going to be finding the length of a path. We're going to be finding the maximum length, but the length of the path will not be the sum of the edges, right? It's going to be the product of the edges, right? Does that make sense? Right. So right here, we put on here an edge with that number. And then as you trail together edges, we'll be multiply them together. Right? Everybody buy that? And then we can talk about, well, what's the running time of this algorithm, right? We can say, how many edges are there? Well, it's the number of states times the number of degree of each node, right? Yeah. Oh, the 0.97 is, well, we are losing 3%, right? Yeah, whatever you have, you lose in every transaction, right? So that's what that is, right? Right. Everybody kind of get the algorithm here? Now we have a graph. You can imagine every path through this graph tells you when to buy and sell, and the product of the weights will tell you how much money you have at the end, right? And if we can find the longest multiplicative path, we'll have the answer, right? And we can get that simply by giving it to the oracle, right? The oracle doesn't care if you're doing max or min or products, right? It just doesn't care, right? All right, so what's the running time? Well, the number of states, which is the number of subproblems, right, is the number of states is t, because we have one for every day, right? And the number of bird answers, the degree here was, remember, she was giving you a stock and she was giving you a time, right? So that's our running time, right? Everybody buy that? We just laid out this graph. It gave us the algorithm. All right, so we want to know if we can do it better. So so instead, we want to, that kind of looked like we had these long edges, right? We want more yes/no questions, or at least fewer answers for the bird, right? So let's try. I'm sitting here on day T and I'm holding stock S, right? It's a different state I'm in, right? And I ask the bird, should I sell it, right? And if I sell it, what stock should I buy next, right? So she's going to say, not should I sell it? When should I sell it? All right. When should I sell it, and which stock should I buy then? Right. So she tells me what day to sell it and what stock to buy instead. Right. And so now it's a different day and I have a different stock. And so if you look at the running time, everybody buy that algorithm, right? But then now the number of states is T times S, and the number of answers she might give is T times S, and that's a lot worse, right? That was no good, right? We didn't want to do that, right? Everybody see we're trying different things, and that's worse. We had more sub-instances, but the same number of bird answers, so that wasn't any good, right? So now we're going to ask the bird, what should we want a smaller question. Yeah, I mean, here I asked two questions. I asked the when, right? And I asked the what do I do, right? What do I do when, right? So yeah, exactly. Right. So we don't want to, the key is we're not going to ask when. We're going to say now. What do we do now? Right. So here I'm kind of asking, what stock do I own tomorrow? Right. And she tells me what stock to own tomorrow. Right. And if it's right, as you say, if it's a different stock, then I'm just moving forward one day. Right. And if they're equal, then I don't have to pay the 3%. Right? We can calculate the cost of all of these edges, right? And it's a little cheaper when you don't buy new stock, right? And so now what's the running time? The number of states is T times S, right? Because we have time and we have stock. But the degree, the number of edges coming out is only S, right? And so now we have two algorithms, one T squared S and one T S squared, right? And are we running out of time? 5 minutes. We can finish this in 5 minutes. Thanks for the warning. All right, so which one's better depends on which is bigger, right? But now we're going to go to what we did for the grad class. Can we do better than this? And this is back to short edges, long edges, right? All that kind of thing. Atomic actions. Anyway, let's go back to what we were doing here. We're going to have on day T, we're holding cash. So what we're going to ask is, should I buy now or not? Right? What do I do now? Should I buy or not? And if so, right, which stocks should I buy or should I hold cash? Right? So here, if she says stock S, right, then you go up to there. And here I'm just putting a little times, right? There's a time you buy and a time you sell. So it's easier to keep track of exactly what's happening. But if she tells you to hold cash, then you go over here, right? So in the morning, if you're going to have cash, you're going to have it at 101. And if you're going to hold stocks, you have it at 103, I guess. But so here you either buy stock or you go to the next day and still hold cash, right? Does that make sense? And right, so what number do I put here? How much cash I have here versus cash here should be 1, right? Because it's the same. Yeah, we're just multiplying. And here, right, you can there's here's a 1. It's kind of a funny that this is a 1, because here I'm holding cash, but here, see, it's almost the same time. So the cash, the stock is the value I bought it at. So how much stock do I have? That same value of stock, right? And then right now I have stock on this day, and she can tell me, do I sell it? Now it's just yes or no. She tells me, do I sell it or not, right? Because I have a stock, right? I can't buy a different stock. I can either sell or I can keep it, right? So if she tells me to sell it, then where do I go? I go over to the day. I go over to I hold that stock on the next day, right? And if she tells me to sell it, right, then I come down here, right? Does that make sense? So it's a little slightly more funny graph, right? But right, and you can add in you can calculate all these and put in the costs, right? Right. And now we want to say how many edges do we have, right? And we have two types of edges, right? We have the light blue and the dark blue edges. And the light blue edges is how many states. Here we have just time states, right? Here we have T of these because it's just time, but we have how many bird answers can she give? She can give me S plus 1 bird answers, right? And over here, well, now there's a T and an S naming the state, right? Because on the time, I have a number of stocks. So that's TS. But then the number of bird answers is 2, right? Because she's just saying, hold it or sell it, right? And so the total number of edges is order ST, right? Which is better, right? Everybody buy that? And that is the great. So we can do the reduction and we can look at our whole graph. And I made them last term give me a whole spreadsheet. And maybe we should do that. Make you do a spreadsheet, right? And there's the graph and the spreadsheet, and we can go through it. But we run out of time, right?